All right, today's lesson is on 10.4. We're going to skip 10.3 for now, and we're going to go on to 10.4. And the section is called Solving Combined Inequalities. Solving Combined Inequalities. There we go. So I'm going to talk about a few vocabulary words as I go through this. We're going to start with a couple of regular inequalities that we're going to graph. So let's see. I can graph something like negative 5 is less than x. And that would look like, let's see, negative 5 and 0 somewhere over here. And negative 5 is less than x. So x is greater than negative 5, and that would look like this. And it would shade all the way up this direction. Okay, and I could graph something like x is less than about 1. X is less than 1. I'll just throw 1 up on here just for the fun of it. So x is less than 1 looks, put it on the same graph. Here's 1. Here's that 0. Throw negative 5 on there. And the graph of x is less than 1 looks like an open circle here and shading this direction. So these are each separate graphs. And what we can do is graph something called a conjunction, C-O-N, junction. And what that is a combined inequality. So if I combine negative 5 is less than x and x is less than 1, we can combine that and say something like negative 5 is less than x, which is less than 1, and x is less than 1. And if I were to graph that, it looks pretty similar to the two graphs above. So we have the 1 and we have the 0. Put the negative 5 in there. And I'm going to put an open circle here and an open circle here, and then shade in between. So that is showing that x is greater than negative 5, and it is also less than negative 1. That's called a conjunction. Right, let me point to it. It's also called an intersection as well. Conjunction or an intersection. And so notice the part of the graph down here that would intersect. So the top graph had everything to the right of negative 5. The bottom graph had everything to the left of positive 1. And the third graph, the last one here, is the intersection of those two. So everything that's greater than negative 5 to the right and also less than 1 to the left. And it's the intersection of what those two graphs were doing. Now, there's also something called a disjunction. One more thing I have to add to the above. So conjunction, intersection, the word and is associated with that. The word and. Conjunction or intersection uses the word and. A disjunction, also called a union, uses the word or. We're going to use the word or. And we can make the same statement. We could say -5. Well, it's almost the same statement. -5 is less than x, or x is less than 1. The difference between the AND statement and the OR statement is that in the OR statement, either one of these has to be true, or either one of these can be true. In the AND statement above, both of them have to be true. Notice in the AND statement, if I pick a value for x like -3, it is true for both statements. It is less than 1. It is also greater than -5. It fits both. Whereas still in the AND statement, if I chose a number like +5, it would be greater than -5, but it would not be less than 1. So it would not be in the answer, in the solution set. Okay. The OR statement, only one of them needs to be true. So if I make my graph, I'll label all the same points. -5, 1, put a 0 in there. So x has to be greater than -5, and so that would be all of these points up here. Or x has to be less than 1. Now, initially, I'd want to put an open circle there and shade all the way to the left. But notice, what was this open circle here and this open circle here has been shaded over by the other statement. So we had an open circle at x is less than 1, but it was shaded over with the x is greater than -5 statement. Okay? Because only one of them has to be true. Now if we pick any number on this number line, like, I don't know, -2 for instance, it works for both. So x is less than 1. It is less than 1. It is also x greater than -5. So that fits. Let's pick a number up here, like +2. Well, +2 is greater than -5, so it fits that. It does not fit x is less than 1, but it doesn't matter. It still counts as a solution because of this OR statement here. It only has to work for one or the other, as opposed to both one and the other. Okay. So know the difference between the AND the OR statement. Disjunction or conjunction AND. So let's go through a couple examples here. So if I wanted to do the graph of the conjunction, we have t is less than 5. No, not t is less than 5. That's the example in the book. I'll let you look at that on your own. I'll give you a new one. So the conjunction of x is greater than -3 and x is less than or equal to -3. Okay, now so let's make the graph. Label our important numbers, which look like just to be -3. And let's put them together. So x is greater than -3 would look like this. X is less than or equal to 3 would shade that in, and look, -3 would go this direction. So what is the overlap? Remember, the AND is the intersection of the two things, or the overlapping part of them. There is no overlap. There's no overlap or intersection because the blue part of the -3 was not part of the answer. It was an open circle, so it didn't count. So that would have been the only overlap, but there is none. So notice if you pick any number like -3 it works for x is less than or equal to negative 3, but it does not work for x is greater than negative 3. If you chose a number like negative 4, it works for this one here, but it does not work for that one here. If you pick a number like 0, it works for a greater than negative 3, but it does not work for less than or equal to negative 3. Okay, so no solution is what we can write for this one. No solution. However, that's if we wanted, the conjunction of those two things. If we wanted the disjunction of those two things, we have x is greater than negative 3 or x is less than or equal to negative 3. That is actually going to be a different graph. So here we go. Let's change the color of that. Let's make it red. Oops. Uh-oh. Technical difficulties. Alright, here we go. We have negative 3. I'll put a 0 in there somewhere. So in the OR statement, either one of these has to be true, or either one can be true. So x is greater than negative 3 is an open circle going this direction. Or x is less than or equal to negative 3. That would fill it in and bring it left. So all real numbers is the answer. Everything works. Okay? Like negative 10 or 1/2 or 3.27. Those are all answers that will work. Alright, I'm going to pause. We can go on to the next video, and then I'll throw a couple more examples up here.